Hello everyone, welcome to the next devlog. Today's update of my little equilibrium simulator in made in Pygame. I've done a couple of updates behind the scene, or a couple of updates since I last did this devlog. Most of it was behind the scenes. Well, not most of it, but a pretty fair amount of it. I added this little class that basically just handles setting everything around the screen, so I don't have to do it manually, because obviously the exposition of everything changes depending on how big the screen is. So now the screen layout is handled for every class is basically handled by this thing. It all lays out properly no matter what size the screen is, more or less. This is a bit over here, stuff's being overlaid, but I don't really care because it fixes itself at full screen. You may notice this thing over here. What is this thing? Well, I've added it. It's new, it's fancy, it's cool. What it does, it's a heater or cooler, so I can raise or lower. I can raise or lower the temperature here. And obviously that will change the equilibrium constant over here. It changes it based on, hold on. Yeah. So here's the equation for it. It's e to the negative reaction delta H times 1,000, because the reaction delta H is in kilojoules, over the gas constant up here, times 1 over the new temp minus 1 over the initial temp, which is 0 Kelvin, or not 0 Kelvin, 0 degrees Celsius, so 273.15 Kelvin, multiplied by our initial equilibrium constant. And if there's a division error, we just set it to 0, if we're at 0 temperature, and then we return that. And so it does. Like if I raise it, the equilibrium constant spikes up, and things happen differently. If I lower the temperature, equilibrium constant falls really fast, and the reaction progresses differently. You can see Q kind of following along the equilibrium, kind of slowing down as it gets closer and closer and closer and closer and closer. The reason reaction 1 and reaction 2 are really similar concentrations is because everything starts at the same concentration. But if I do like 10, 20, 30, it should be all out of whack, and then you'll see what I mean. Yeah, see, now they're all different, right? And I'm going to let it settle to equilibrium, and then I'm going to raise the temperature. And oh, look, it's diverging, because since the K is higher, now we're favoring the products more. Raise it even more. Now we're really favoring the products, And these concentrations here are falling. Even more. It's going to start bugging out, yeah. And this scale, by the way, is dynamic. You don't understand how long it took me to figure out how to get this scale to be dynamic with how many decimal places are here. Anyway, let's lower the equilibrium constant. Because see what I mean? Earlier it was in ones, and now it's by, 0.3 or something. I don't know. Anyway, so we lower it. Obviously, the equilibrium point changes. If we lower it further, if we cool it further, it changes even more, and it falls down to 0. Unfortunately, it kind of bugs out at really low temperatures. It kind of falls to 0 because we lose precision. And things just start getting weird at 0 Kelvin, but I guess that's how normal things happen. Okay, it looks like there was an error somewhere. That's fine. I don't really care right now. I'll fix it later. In the future, I'll make it so that the speed of these particles reflects the temperature, and it bugs out at really high temperatures too. So if I crank the temperature, you'll notice some weird things start to happen once the constants, see. So I think what's happening is we're losing precision here, and things just start going insane. Honestly, I don't even know what's happening. Oh, it's stabilized. That's interesting. Hasn't happened before. What if I go farther? Because I know at some point I went so high that it just like straight up crashed. We should be getting right around that point. Yeah, so see, the concentration of the products is spiking for no reason. And there's the crash. I wonder why this is happening. I don't know. Doesn't matter. I'll fix it later. Obviously, that does not correspond to reality. I don't actually know what's up with the equation. If you know what's up with the equation, just let me know in the comments, because I don't actually know what's going on there. Anyway, that's all I've got for today. Thank you very much.